Hey, what is going on, guys? Mr. C here. Hope you guys all had a good Easter break. It's good to be back. I miss you guys. We last left off talking about parabolas. We're going to be talking about ellipses today. Ellipses, you may know them as ovals. They're kind of like circles. They're just one axis is a little wider than the other, whether it's stretched horizontally or stretched vertically, rather than a circle that's even all the way around. So ellipses are basically just ovals. Let's go ahead and look at the equation for an ellipse. It's similar to the equation for a circle. Right here is where we're looking. Okay, it says x squared over a squared plus y squared over b squared is equal to 1. And then they give us this equation here, b squared equals a squared minus c squared. So let's go over the different, because there's a lot going on with an ellipse. Let's go over the different points. Okay, so as an equation of the ellipse with at center 0, 0, which it's important to note that everything that we're going to be doing today, the ellipses are at 0, 0. Okay, foci at negative c, 0 and positive c, 0, and vertices at negative a, 0 and positive a, 0. Now, the foci work a little bit differently in ellipses than they do in parabolas. They're not like, they're going to be on what we call the major axis. So these foci here are on the major axis. Now, how do we know which one's the major axis? This guy here is stretched horizontally, as you can see. Okay. So that means the major axis is this one that goes through these vertices. So we call this vertice 1, vertice 2 here. You can consider them major vertices since they're on the major axis, and then this part here, you can kind of consider those the minor vertices. Okay, but typically if we just say vertices, we're talking about the ones on the major axis here. If this was stretched vertically, this would be the major axis instead. Okay, but you can see here, the major axis is the x-axis in this example here. Okay. So those are the foci. The foci are basically just, if you pick any point, let's say I draw a point, whoopsie, okay, let's say we draw a point on this focus. Okay, if I connect that point to the two vertices, so this and that here, oh no, to the two foci, sorry, it would be this and that. Okay, how it works in an ellipse is that the sum of these two red lines is the same as the sum of these two, this dotted line here and this line. I believe that's what it is. Let me just double check to make sure I'm saying the correct thing. An ellipse is the collection of all points in a plane, the sum of whose distances from two fixed points, called the foci, is constant. So that's exactly what I just said. Pick any point on this focus. Again, I can pick a different, or on this ellipse, I can pick a different point, say over here. Let me use a different color. If I connect to the two foci, okay, if I took the sum of these two blue distances, that'd be the sum of these red distances, or it'd also be the sum of these, this dotted line here plus this one here. Okay, so the sum of those two distances are the same. Okay, that's what the foci give us. All right, in case you're wondering what the heck those were. All right, so I know I just kind of explained a lot, but let's go ahead and look at an example, right? Because I think that'll help us better connect what we're looking at. So it says, find the equation of the ellipse with the center at the origin, one focus at 3, 0, and a vertex at negative 4, 0. So I'm going to kind of do a little sketch just so we know where things are. Okay, it says I have a foci at 3, 0 and a vertex at negative 4, 0. Let's see. Let's say here's negative 4, 0. It's not drawn to scale. Here's positive 4, 0. We also have a focus at 3, 0. Okay, how did I know we'll have a vertex? So let's say this is V1 and this is V2. If we're at the center and I have a vertex at negative 4, 0, you're going to have one at positive 4, 0. It's got to be the same distance away, right? So that's kind of what we have. We should know that the other focus is the same distance away. Here's F2. So let's say this is negative 3, 0. This is positive 3, 0. Okay. What I don't have are the minor vertices. Okay, I don't know how high this is stretched, so I don't know if it's like this, or I don't know if it's like this, or if it's stretched a little more. Okay, I'm not sure. So that's what we're going to find using this equation here. Okay. Remember, C were the focus points. A is my vertice points, okay, on my major axis. So if I'm trying to find the B, again, that was B squared equals A squared, which in this case is 4. So A squared is 4 squared minus C squared is 3 squared. So we should have B squared equals 16 minus 9. 16 minus 9 gives us a brain fart, a 7. Okay. B squared is 7, which gives B to be the square root of 7. Okay. So basically what we're saying then is square root of 7 is between 2 and 3, I know. So this other vertice point here should be 0 root 7, and my other one should be 0 negative root 7. Okay, and my ellipse should look like this. Okay, over just a little bit. Okay, but they didn't ask me to graph, they wanted me to just find the equation. So that's what the graph would look like. The equation, we have A, right? We have C, we have B. We should be able to plug those right in. So my equation is x squared over a squared. Again, A was 4, so a squared is 16. X squared over 16 plus y squared over, we said B was root 7. Root 7 squared is just 7. This is equal to 1. Okay, that's going to represent my equation. All right. We're going to do another one. Don't worry if that was kind of confusing. We'll do one more. The next one we're going to do is going to be stretched vertically. So how that changes is, okay, take a look at this equation. This is for stretched horizontally, okay? The only thing that changes if it's stretched vertically is these two, okay? A and B will switch. Basically think A is always the greater number, okay? A is always going to be your greater number. So if you have a greater number under the Y, it's going to be stretched more vertically than it is horizontally, okay? So let's take a look at this next example. Right here, find the vertices and foci for the equation 9x squared plus y squared equals 9. Okay, so it's not really written in standard form. It doesn't really look like the other one. Remember the other one, I have a x squared over something plus y squared over something is equal to 1. So what I want to do here is I want to make this number equal to 1. So the way I have to do that is divide both sides of my equation by 9. So divide everything by 9. Okay, that's going to give me an x squared plus y squared over 9 is equal to 1. Okay, x squared plus y squared over 9 is equal to 1. Right, now, is this being stretched vertically or horizontally? Well, the number under the y is larger than, we don't see anything here. Technically, there's a 1, okay? So think about that b as being 1. So since the number under the y is greater, it is going to be stretched vertically, Okay, so let's think. Okay, vertically it's going to stretch all the way. Let me draw this a little bit bigger. Okay, vertically it's going to be stretched. If b is, well, if this is 9, that's b squared technically. So, well, I'm saying b, it should be a, because a is always the greater number. If this is 9, then 9 is a squared, which means a should actually be 3. B is still going to be 1, and we're going to use that information there to find where our focus is going to be. So, again, that goes 1, 2, 3 up here. 2, 3 down here. So this is 0, 3, 0, negative 3. The B was 1, so that's 1, 0, negative 1, 0. Okay, looks like this. Okay, that'll have to do. Right, so we need to figure out where on this major axis is, or are our foci. So we use that equation, b squared equals a squared minus c squared. So 1 squared equals 3 squared minus c squared. 1 equals 9 minus c squared. Subtract the 9, you have a negative 8 equals negative c squared. Multiply both sides by a negative to cancel that. A equals c, or 8 equals c squared. And c will equal the square root of 8, which is 2 root 2. All right. So that should be where my focus is, 2 root 2. 2 root 2, let's figure out exactly where that is so I know where to draw those. I know it didn't ask us to graph, but 2 root 2. It's about 2.8, so that's pretty close to this 3 here. So we'll have 1 here, 0, 2 root 2. Down here, that's 0, negative 2 root 2. Okay, so those are our vertices and our foci. Remember, vertices are these two. Okay, technically their vertices are only on the major axis. If you wanted to name these, you could call these minor vertices. But when we're talking vertices, we're only looking for the ones on the major. And then these are my two foci, F1, F2. Okay. All right, that's all I have for Monday and Tuesday. We're going to take it a little slower for you guys because you guys are almost done. I heard they might even be moving your guys' final day to, the beginning of May. So congrats if that actually happens to you guys. Look forward to seeing you guys. Hope we can somehow celebrate some way, your guys' graduation, because it is a big deal. So I'm super proud of all you guys. Yeah, it's kind of weird. Just I'm sitting in the basement talking to myself, trying to explain how proud I am of you guys. It doesn't really feel, I don't know, it just feels strange. But I'd rather see you guys. Miss you guys. Hope you're doing all right. Yeah, that's all I have. Talk to you guys later.